Here's the thing. We need energy, a lot of it, but we also want a healthier planet. So what if we could take one of our oldest power sources, coal, and make it cleaner and way more efficient? Today, we're going to dive into a fascinating piece of engineering that tries to do just that.
So, how do you make a coal plant cleaner? I know, it sounds kind of like a contradiction, doesn't it? Well, the answer, surprisingly, is found in the really strange physics of water when you put it under extreme, and I mean extreme, pressure.
Okay, so before we get to the solution, we've really got to understand the problem. It's this global search for efficiency in a world that, for now, still largely runs on fossil fuels. Look, for many countries, fossil fuels are they're the bedrock of their energy security and their economic growth. But yeah, the environmental cost? It's huge. So the challenge isn't just about flipping a switch to renewables tomorrow. It's also about making the energy sources we rely on today as clean as they can possibly be. And the scale of this opportunity, it's just massive. I mean, take India, for example. A staggering 80% of its power from fossil fuels comes from older, less efficient technology called subcritical boilers. That represents a huge potential for improvement just by upgrading the tech. So, where does this big improvement come from? Well, the secret is hidden in something we all see every single day: water. But this is not the water you boil for your morning tea. Nope, we're about to unlock a strange, incredibly powerful, almost alien state of matter. Okay, say hello to supercritical water. Here's what happens. You heat water above 374 degrees Celsius, that's over 700 Fahrenheit, while keeping it under more than 220 times normal atmospheric pressure. That's an insane amount of pressure. And when you do that, something really amazing happens. It hits what's called its critical point. Okay, let's really break this down. So on this diagram, you got temperature and pressure. Now in a normal old-school subcritical boiler, you heat up liquid water, it hits this line right here, the vaporization curve, and boom, it boils into steam. Simple enough. But check this out. In a supercritical boiler, you ramp up the pressure so high that you go completely around that boiling point. The water never actually crosses the line. It never, technically, boils. So, what in the world is this stuff? It's not really a liquid anymore, but it's not quite a gas either. It's this weird hybrid state, a single, super dense, super energetic fluid. Honestly, the best way to think about it is like steam on steroids. It holds way more energy to spin a turbine. All right, so now that we know what it is, let's put these two technologies head to head to see how this one scientific principle changes absolutely everything inside a power plant. This is kind of a tale of two boilers. And the difference is pretty clear, right? Subcritical tech works below that critical point of pressure and temperature. It relies on good old-fashioned boiling. Supercritical technology, though, it just blows right past those limits, creating that unique fluid without any boiling at all. And that is the fundamental game changer. And you know, what's so elegant about this is that the plant layout doesn't have to radically change. You've still got your generator, your turbine, your condenser, all the basic parts are there. The real innovation isn't some brand new, crazy machine. It's a new, way more powerful process happening inside a framework we already know. Okay, so we've made this weird, super energetic fluid big deal, right? So what? Well, let's connect this science back to the real-world benefits. This is where we see the efficiency payoff. All right, let's talk numbers. A typical subcritical plant, the old-school kind, converts about 40% of the heat from burning fuel into actual electricity. A supercritical plant, thanks to that more energetic fluid, it can get up to around 46%. Now look, I know a 6% jump might not sound like a lot, but for a massive power plant that's running 24/7, that is a huge leap in performance. So here's the crucial point. What does that efficiency gain actually get us? Well, it means you burn less fuel to make the exact same amount of electricity. And that leads directly to reduced fuel costs and, most importantly, lower emissions. Less CO2, less soot, less pollution for every single kilowatt hour you generate. You know, one of the sources for this explainer puts it perfectly. It says that increasing efficiency is a direct solution to reducing pollution. In a world that's desperately searching for ways to cut emissions, just doing more with less, it's one of the most powerful tools we've got. But, you know, the story doesn't end here. Supercritical tech isn't the final step, not by a long shot. It's really just part of an ongoing evolution. The future is getting even hotter and even more efficient.
Engineers are always pushing the boundaries, right? The next steps are called ultra-supercritical and then advanced ultra-supercritical plants. We're talking about operating at even more extreme temperatures, up to 760 degrees Celsius, and insane pressures, all in the chase for even greater efficiency gains and, you guessed it, further reducing emissions.
You'll actually hear a term for this in the industry. All of these advanced plants, supercritical, ultra-supercritical, and beyond, they're often just grouped under one umbrella term, HEL. It stands for high efficiency, low emissions. And that's really how they're framed as a key part of the transition to a cleaner energy mix.
And that brings us right to our final thought. We've seen how this technology can seriously reduce the impact of fossil fuels. So the big question we're left with is this. Is making our existing power sources more efficient a necessary, practical step on the road to a cleaner world? Or is it just a distraction from the ultimate goal of a fully renewable future? It's a really complex debate, and it sits right at the heart of our global energy strategy.